Welcome back. Okay, today's review topic is trigonometry. I think we're on notes number 6. So in pre-calculus, we studied trigonometry from February through May, pretty much. That's a lot of trigonometry, and that's a lot of things to talk about all in one day. So I'm going to hit the highlights and do the things that are the most important. This will probably end up to be 2 videos. So let's jump right in. Here we go. Okay, let's talk about radians. So we can measure angles in degrees, or we can measure angles in radians. And we might be more comfortable with degrees, but in calculus, the default is radians. So let me remind you that a radian is the angle that you get if you have a central angle in a circle whose radius, we'll call that length r, is equal to the arc length. So if that length there is r and the radius is r, then the measure of that angle is 1 radian. And it's roughly 57 point something degrees. Now the relationship between degrees and radians is that 1 full circle is 360 degrees. So that means 1 full circle is also 2 pi radians. If you divide that in half, then you have the conversion factor. 180 degrees is pi radians. So we use that conversion factor to figure out any other angles radian measure, or going the other way, it's degree measure. So if you had 30 degrees is 1/6 of 180. So 1/6 of pi over 6 radians. If you had 90 degrees is 1/2 of 180. So 1/2 of pi is pi over 2 radians. So typically I like to think about it in terms of fractions. What fraction of 180 degrees do I have? What if you had something like 450 degrees? There's a lot of different ways you could think about it. You could think of this as 5 times 90. And we know that 90 degrees is pi over 2, so 5 times pi over 2 radians. So we could just call that 5 pi over 2. We also have a proportion. The proportion is the degrees over the radians is equal to 180 over pi. And that proportion can be written in a variety of different ways. But what you can do is, if you know the degree measure, you can plug that into the proportion, use x for the radian measure, cross multiply and solve. Or if you know the radian measure, plug that in, use x for the degree measure, and solve. So what about converting from radians to degrees? Well, let's say you have 3 pi radians. Every time you have a pi radians, just replace it with 180 degrees. So 3 times 180, and that's 540. Or what if you have 2 pi over 3 radians? Again, replace the pi with 180 degrees. So 2 times 180 divided by 3. I'm going to take 180 and divide it by 3 and get 60, and then multiply that by 2, and that's 120. Okay, let's move on to another topic. All right, let's review the graphs of trig functions. We have 6 trig functions. We'll spend most of our time focusing on the main 3, sine, cosine, and tangent, but I don't want you to forget that there are 3 others, secant, cosecant, and cotangent. So y equals sine of x. We're going to draw this from negative 2 pi to 2 pi. Those were horrible axes. Sorry, I'm going to do that again. That's a little bit better. So suppose I put 2 pi right here and negative 2 pi right here. That would be like going 1 time around the circle. I'm going to split the interval from 0 to 2 pi in half, and then split each half in half, making 4 different parts. And then I'm going to do the same thing on the other side, split it in half, and then each half gets split in half. On the y-axis, I'm going to go up to 1 and down to negative 1. Remember, the largest sine can be is 1, and the smallest is negative 1. So the sine of 0 is 0, so it goes through the point 0, 0, and then it goes up to 1, down to 0, down to negative 1, and back to 0. That's 1 full cycle of the sine graph. So let me tie that into something else. Remember exact values where you have your unit circle. And on the unit circle, if you're finding like the sine of 0, the sine of 90, something like that, you use the point on the unit circle. So that point has coordinates 1, 0. The x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. So the sine of 0 degrees is 0. The sine of 90 degrees, this point would be 0, 1. So the cosine is 0 and the sine is 1. The sine of 90 degrees is 1. That's where we got this point right up here. Over here, this point has coordinates negative 1, 0. So negative 1 is the cosine, 0 is the sine. So that would be 180 degrees with a sine value of 0. That's how we get this point right here. And so on and so forth. And then we know that that pattern is just going to repeat infinitely many times. So over here I can draw another one of them. Remember that we use the word period to stand for the width of one cycle. So for the sine graph, the width of one cycle is 2 pi. We also use the word amplitude to stand for the distance from the middle to the top, which is also half the distance from the bottom to the top, so the amplitude is 1. Unless, of course, you have some kind of transformation. In that case, that's going to possibly change the amplitude or change the period or both. Okay, so how about y equals cosine of x? Remember, this is review, so I need to kind of just hit the highlights here and not give you the entire lesson all over again. Let's do the same thing. Divide those in half and then in half again. Go from 1 to negative 1. The cosine graph, since the cosine of 0 is 1, the cosine graph starts up at a height of 1 here and goes from the top to the middle to the bottom to the middle to the top. One complete cycle. Make sure you make it nice and smooth and curvy, not straight or pointy. I'll do another one over here. Okay, the period is 2 pi, the amplitude is 1. And now let's take a look at the tangent graph. Remember that tangent is undefined at places, so tangent actually has some vertical asymptotes. So let's see, on the x-axis this would be pi, so this would be pi over 2. There's a vertical asymptote at pi over 2, that's where tangent is undefined, so we draw a dotted line. And also every pi units from there, so at 3 pi over 2, at negative pi over 2, at negative 3 pi over 2, and so on and so forth. And then in between we have these curves that look like this. If you're stopping at 2 pi, then you can just draw half a curve. If you're not stopping at 2 pi, you could keep going and draw the rest. It just depends on what the instructions tell you to do, whether they tell you to stop there or not. Okay, now what about the other 3 graphs? So remember that cosecant is the reciprocal of sine. So if I want to graph y equals cosecant of x, I'm going to look at the sine graph. And everywhere that sine is 0, the reciprocal is undefined. So vertical asymptotes. Everywhere the sine graph was 0. Everywhere the sine graph was 1, the reciprocal of that is 1. So we have 1s. And everywhere the sine graph was negative 1, the reciprocal of that is negative 1. So we have 1s and negative 1s that alternate, and then we end up with curves going up, curves going down, alternating like so. By the way, I forgot to talk about the period of the tangent graph. So the width of one cycle is just pi. The sine graph had a period of 2 pi, the cosine graph had a period of 2 pi, the tangent graph has a period of pi. For cosecant, the width of one cycle would have one curve going up and one curve going down, so the period is 2 pi. For the amplitude, let's talk about the amplitude of tangent as well. So If amplitude is the distance from the center to the top, but it goes up infinitely far, then there is no top, so the amplitude is undefined. Same thing with cosecant, amplitude is undefined. Okay, for the secant graph, we would take the reciprocal of the cosine graph. So that's going to happen just like the other one I just did, where you have vertical asymptotes everywhere cosine was 0, and you have reciprocals, you have curves going up and curves going down. So I'm going to put those asymptotes in place where the cosine graph was 0, and then I'm going to put the 1's in place and the negative 1's in place. Curves going up, curves going down, alternating. And if you're stopping at 2 pi, then you draw half a curve over here. If you're stopping at negative 2 pi, you draw half a curve over there. Amplitude is undefined, period is 2 pi. And then let's do the cotangent, the reciprocal of tangent. So we're going to take a look at the tangent graph. Everywhere the tangent graph is 0, the cotangent has an amplitude. So that would be at 0, and at pi, and at 2 pi, and at negative pi, and negative 2 pi. And then everywhere that tangent had a vertical asymptote, cotangent has a 0. So in between the vertical asymptotes you have a 0. And instead of curves going up, we have curves going down. Amplitude is still undefined, and period is pi. Okay, hopefully that jogs your memory a little bit. Let's see what's next. Let's review our trigonometric identities. This is a unit that we did entirely from home last spring, and I definitely cut it short compared to what we would typically do. Typically we would learn 24 trigonometric identities, and you guys only learned 8, but those were the main 8 that you would use the most often in calculus. And look, here we are in calculus. So, super, it's going to work out. The Pythagorean identities look like this. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. Cotangent squared theta plus 1 equals cosecant squared theta. It doesn't have to be theta, it could be x or alpha or whatever letter or variable you want to put in there. These things are always true for all angles for which they're defined. Reciprocal identities, we have secant theta is the reciprocal of cosine, so 1 over cosine theta. We have cosecant theta is the reciprocal of sine, so that's 1 over sine theta. And then we have cotangent theta is the reciprocal of tangent. So we already talked about those a little bit when we were drawing those graphs. And then ratio identities, we have tangent theta is equal to sine theta over cosine theta. And we have cotangent theta is equal to cosine theta over sine theta. So identities are often used to do substitutions to make an expression simpler, replace something more complicated with something that it's equivalent to. Okay, here's a biggie, exact values. I think this would be a great time for me to pause part 1 video and make part 2 video. So come back for part 2, we'll do exact values.